Hey Algebra 2 students, I wanted to do a short video going over some extra examples that I didn't get to in class. We ran a little short on time, and I'm going to throw in some extra comments just to kind of help you with the homework. Okay, and the most important thing was what happens when you combine all the different transformations together. The key thing you need to know is you need to do the stretch and compression transformations first before you do the translation right, left, and up and down. Also do the reflections first. And you'll notice that stretch, compression, and reflection are all multipliers. You're either multiplying x by the b parameter, or you're multiplying the whole function. You're multiplying y by the a parameter. And this is... let me do this and then this. So this was let me show you a couple different things. So I'm going to show you some Desmos, and I want to show you this. So this was the document that we looked at that had the summary of all the transformations you need to know. And the B is a multiplier, A is a multiplier. B is the horizontal stretch, compression, and reflection over the y-axis. So that's all the horizontal stuff. A is the stretch, compression vertically, and also the reflection over the x-axis, so a vertical reflection. You'll notice that these parameters correspond to A and B up here in the table. Okay, so for example, B times X on the inside is either a horizontal stretch or shrink, depending on whether B is greater than 1 or B is between 0 and 1. And then what we do is we handle, if B is negative, we handle the negative separately from the stretch and compression. This is super handy, and this middle column explains what happens to a single point, like a single point xy. So if xy is a coordinate point that's on f, the original function, when you graph f of bx, you're transforming f, and what happens to the xy point? Xy gets mapped to x over b, comma y. So if b were 3, so this were f of 3x, then all the x coordinates would get divided by 3. So all the x coordinates of, this is the y-axis, all the x coordinates are going to get multiplied by 1/3 or divided by 3, and that's going to squish it in by a factor of 1/3, or multiplying, by a factor of 3, which is multiplying all the x coordinates by a factor of, multiplying all the x coordinates by 1/3. Okay, so the middle column here shows what the transformations do to single points. Over here is a description of what you would see the whole graph do. Okay, let's look at let's actually look at Desmos. So here's an example, and this is a piecewise function, and the definition doesn't matter too much, but it is the red graph, and it's f of x. And it would be good for you to pause and think, what would g of x look like? G of x is f of 2x. So if you pause the video, you could try to draw it and see if you're correct. Okay, so f of 2x means that I'm multiplying x by 2. That's the b parameter, this one. And it's 2 in this example. So that's b is greater than 1. So we're going to have a horizontal shrink or a horizontal compression. And we're going to divide all the x coordinates by 2. So that has the effect of squishing the graph in. What used to be 1, 1 up here became 1/2, 1. The x coordinate got multiplied by 1/2, or the x coordinate got divided by 2. Okay, now this one is fairly straightforward, and we've looked at this one already. This is a left transformation by 2. So if f is the red graph, h of x is a left transformation by 2 units. Now, where we run into issues, there's a couple different issues, is if we have 2x plus 2 here, we see that there's a 2 multiplier and there's a plus 2 here. Now, your first guess would be that this is going to compress the graph horizontally by a factor of 2 or multiply by 1/2. And that's correct. And this looks like it would be a left transformation by 2, but it turns out it is not. So if we look at this, it's actually this graph. Remember I said earlier, always do the compressions first, stretch and compression. So if we first compress f by this, so it gets squished in, that's the one we already saw. Can you see that the blue graph, m of x, is 1 unit to the right of g of x? So what's going on here? It's not a 2-unit transformation to the left or translation to the left. And here is what you need to know. When you have a transformation that includes a b value that's not 1 and an h value that's not 0. So in other words, there's going to be a horizontal stretch or compression, maybe a horizontal reflection, and there's going to be a horizontal translation. If that's the case where there's both of these, then you need to factor out the coefficient in front of x. So I would be left with x plus 1. And what you will see is, I'll make it green. What you will see is that green graph is the same as this. And we can now see the transformations completely. When it's factored like this, you do the multiplier first when you're doing your transformations, and this is going to compress. It's going to squish it in inward towards the y-axis, and this is going to translate it left by 1. It only goes 1 unit. So you would the b is 2, so that squishes it in by 1/2. This is a translation to the left by 1. All right. Let's go to, yeah, okay. So let's look at this example. So here's an example that's in the, let me make this full screen. Okay, good. This is an example that's in our packet, our classwork examples and problems that you could do for homework. Oops. Okay. The original given function is this, and the parent graph is going to be x squared. So the parent function is over here, and the parent function is x squared. Now, to be able to see all the transformations accurately, you notice that on the inside the parentheses, it's 2x minus 6. We need to factor that 2 out and that on the inside, and that becomes 2 parentheses x minus 3. And now we've got it in a form where we can see all the pieces. So the a coefficient is -1, so that's going to be a reflection over the x-axis. The b is 2, so that's squishing it in by a factor of 1/2. And this is going to be a right translation by 3 units. H is 3. And because that's a minus, it would be to the right. It's the opposite of what you'd expect. Now out here, it's what you do expect. If we add 4 units to the, if we add 4 to the y coordinate, it's going to shift the graph up by 4 units. So what we can do is we can think about these transformations in steps, one at a time. So the original function is f of x equals x squared. And a point on that graph would be x comma y. Let's just call it that. First, remember I'm saying do the multipliers first. Don't do the translations first. Let's do the multiplier by x. The multiplier by x is 2, that's b. And if we go back to the, if you look at the table that we looked at a little while ago, when you have the b as 2, that takes all the x coordinates and divides them by 2. That's why it gets squished in, all the x coordinates cut in half. Okay, the next transformation is the a coefficient, and that's out here. The a coefficient is -1. So now I'm multiplying all the y values, the outputs, by -1. So that takes the green points on this graph and it multiplies all the y coordinates by -1. So that flips the graph over the x-axis. The next transformation we can do is the horizontal translation, because I've already done my multipliers, so now I can do my translations. Since there's a -3 in here, this is a right translation by 3. So what does that do to the point, to these purple points? It translates the x coordinate to the right by 3. Because remember, when this is subtract 3 in here, that shifts the graph to the right by 3. So it takes all the x coordinates and adds 3. So that's a shift to your right. Finally, we're going to translate the graph up by 4. And that takes the previous points on this graph and it adds 4 to the y coordinate. So we had already flipped it over, so it was -y. And now we get -y plus 4. Okay, so let me show you in Desmos what that looks like. In Desmos, that will look like the following. So the original function is, let me make this a little easier to read. I think that'll be a little bit easier to read on the screen. Okay. The original function is f of x equals x squared. Multiplying by 2 on the x squishes it inward. This was 2 comma 4. And that became 1 comma 4. And 1 comma 1 became 1/2 comma 1. Okay, then we reflect over the x-axis by that negative, and we translate to the right by 3, and we translate up by 4. And our final graph, if I turn all these off, that we want, our final graph is this, and that is equivalent to, that is equivalent to what we were given originally, this original function here. In Desmos, I typed it like this to show all the transformations. Okay, and also notice the original vertex is 0, 0. So what does the set of transformations do to the vertex 0, 0? Well, I can go back here and I can say, what does 0, 0 become when it's transformed into G? Well, I actually have the formula for what to do right here. It becomes 0 over 2, because the original x is 0, so that becomes this x, 0 over 2 plus 3, and then -0 plus 4. So I just plugged everything in, and I get 3 comma -4. So the original vertex was 0, 0. The new vertex better be at 3, -4, and we can come back here and, we can come back here and look at it, and I can graph it. The original vertex is 0, 0, and the new vertex is 3 comma -4. Oh, excuse me, 3 comma 4. Oh, oops, I made an error. I just realized this was a minus here, but I was adding 4, so I need to erase that. The new vertex is 3 comma +4. So I'll come back here. And we've got these. Old vertex transformed to the new vertex. And what about this point 2, 4? 2, 4 here becomes 2, 4 becomes 2 over 2 plus 3, comma, negative 4 plus 4, or 1 plus 3 is 4, comma, 0. So let's go back to the Desmos graph and plot 4, comma, 0. So this point here, 2, 4, becomes 4, 0 after the transformation. So we can figure out where single points go from one graph to the next. Okay, just a couple comments. This is an example in the packet, which I won't completely talk out, but it has a sequence of transformations that's very similar. So you will see a sequence of transformations happening, and it's good to graph them one by one. And the final result would be this. You can check all your answers in Desmos, by the way. I recommend it. And if we go back to here, then a couple notes. Remember, we want to be able to do the transformations of this. We want to get this in the form of A f of B x minus h plus k. And what we have here is A square root of, and out here this is k, no problem. But the problem is we have this stuff not in the correct order. So we need to factor in order to make that happen. So to rewrite this, we would factor out a -1, and we would get -4 plus x. And then we can reorder the addition here, and we would get -x minus 4. And then plus 1 on the outside. So I've taken the original and I've rewritten it this way, and now I can accurately see all of my transformations. I know it's a horizontal reflection over the y-axis. It's a vertical stretch by a factor of 3. For the vertical one, if the value is greater than 1, it's a vertical stretch. It's a translation to the right by 4. That's a minus. It's the opposite. So it's the right by 4. And this is a translation up by 1. Similarly, in some of the other examples, this one's fairly straightforward. The multiplier is not a big deal. But for this one, you will need to factor out the -2 on the inside to get this in a form where you can see what's going on here. And that's actually the graph I showed you in Desmos. Okay, so that you know enough to do every problem on every packet that I have given you so far. So go try and do as many of them as you possibly can, and that will prepare you for the mid-chapter assessment on graph transformations. This was the toughest stuff that I had in this video, and it was the last kind of example. I expanded on it here because I had a little more time with the video, but this is the last example I was going to do. All right, I'll see you next week.